All right, so today, briefly talk about sustainability, and then we're going to start really digging into, we've looked at some of the problems and the pros and cons what we currently have, and then we're going to go ahead and kind of moving forward, look at ways that we can make all of these processes a little bit more sustainable. So first, just so we're clear on what sustainability actually means, it's just that we're using a resource in a way that's not going to degrade or deplete it for future generations. So we're using it in a way that's going to make sure that it's available forever and ever and ever, if that's what we want to. So the example I gave you here is the idea that we want to use compost over like a synthetic fertilizer, right? Because a synthetic fertilizer is going to be fossil fuel dependent. That's not really something that's a sustainable system in general, but compost is a renewable resource that we can continue to use. So that's a good one. The other thing that we think about with these is what we call maximum sustainable yield. So it's how much of that renewable resource we can use without depleting it. So it's figuring out what is the actual yield of that resource. The idea, again, is kind of looking at how the population is growing, where we can harvest it kind of to keep it in this fast growth area. Because if we can harvest enough to keep that population size where it's quickly growing, we continue to keep that resource renewable. And keep in mind too, when we say non-renewable and renewable resources, there's a lot of things that fall kind of in between there that can be renewable if they're used correctly. Truthfully, if fossil fuels are one of them, right? Fossil fuels technically could be a renewable resource if we were able to use them sustainably. So just kind of keep that distinction in mind. So one of the things with our current agriculture system that is really difficult is how we treat for pests and how we try to maintain those. And oftentimes they involve lots of chemicals and lots of sprays, or, some of those processes where we monocrop or things like that. So moving forward, one of the more sustainable ways of controlling pests is what we call integrated pest management. And integrated pest management, the idea is that we're going to use a bunch of different control methods to try to minimize pesticide use and environmental disruption. And there's lots of ways that we can do this. It's definitely more time consuming because it does involve researching and monitoring pests. So we have to know a little bit about the pests that we're looking at and know a little bit about their life cycle. And then we have to kind of look at a whole bunch of other things, right? And it takes a while to get that squared away. Don't worry so much about this diagram. One of the things that we often will do with IPM, or integrated pest management, IPM for short, right, is biocontrol. So biocontrol is the idea that we might bring in a natural predator or parasite to help control. It's a great system. Again, we have to know a lot, though, about the ecosystem. We have to know a lot about the target pests that we're trying to get rid of, because bringing in something, we also want to make sure that we're not going to throw off the ecosystem. Like, so for example, there's a classic example in Hawaii where they were having an issue. I should have looked this up before I started this video. I don't remember exactly what it is. They were having an issue. I want to say it was like a beetle of some sort. So they brought in, I think it was cane toads to eat the beetle. The problem is that the beetle was active during the day and cane toads were active at night, or something along those lines. And then they decided, okay, now we have a cane toad explosion. They brought in something that would eat the cane toads. But the problem is that the cane toads were poisonous, whatever it is they brought in. So then those things died. It was this whole big mess. So we have to be careful with biocontrol. Moral of the story. Because we need to make sure that we're doing it responsibly. The other thing that we can do, another tenet of IPM, is what we call crop rotation and intercropping kind of combined. So it's the idea that if we rotate where our crops are planted, we can kind of keep pests from becoming like endemic, I guess we'll use that word, to this area. So for example, let's say I have squash, and squash borer beetles are terrible for squash. They are going to maybe eat that crop or whatever they're doing, but then they're laying their eggs and their larvae are in that soil, right? So if I plant squash there again next year, those larvae are going to hatch. Those beetles are going to do the same thing. However, if I plant a crop there that I know those squash borer beetles can't hurt, when they hatch, they have no food source. They're not going to make it. So by rotating our crops, we can limit that. The other thing we can do, again, is intercrop. And a lot of times with intercropping, I'm going to kind of get into this later, we can plant crops that will actually like pull pests away from one plant, like that don't hurt the other, and we can then kind of monitor it that way. So I already went through a lot of this in the slide, so I'm sorry, I did a bad job with these, but you get the idea. So I already went through kind of the gist of this. Sometimes we will actually purchase and spread the organisms themselves. Other times we just sort of like make them go there. So like, for example, I have a little garden in my backyard, and praying mantis are amazing for controlling aphids, and I had an aphid problem. We were here, and our entomology class actually found like a little egg sac, and I took that home. and I put that in my garden. So I had lots of little baby, praying mantises around. So I kind of did my own little biocontrol. Other times we, again, will just kind of like provide habitat that would attract them. I already mentioned kind of the crop rotation thing, so I can kind of go through this. The one thing I didn't mention, though, is that it does disrupt weed growth because you can, again, plant at different times. So we also can limit the amount of time there's bare soil, which is not a great thing. That leads to lots of other issues, too. All right, intercropping, I'm going to talk a little more because this is what I was talking about on the other slide, but I wanted this image. So the idea of a push-pull system. So push plants are typically going to be something that's going to like emit some kind of chemical that's going to repel the pest away from the crop. And then pull plants are going to be something that are going to attract it. So for example, you can see in here, we have the corn borer moths. And again, it's kind of like squash ones are going to eat everything. Desmodium produces a chemical that those don't like. So it's making it so the moths are going to leave the corn in general. The Napier grass is actually a really good habitat for them. They like to like lay their eggs there. So the Napier grass is going to pull those. So the Desmodium is pushing them away, and the Napier grass is going to pull them in, and it'll at least lay those away from the crop. So again, we don't necessarily need to kill them. Like they're still part of the ecosystem. We just don't want them in our crops. So we move them to different locations. And again, as part of that, we also are oftentimes providing habitat. So let's talk about pros and cons because everything has pros and cons, right? Interruption. Morning here. Anyways, pros and cons because there's always pros and cons. One of the benefits is that we're going to help the non-target species not get hurt. So a lot of the pesticides like you see here had negative effects on non-target species. We're going to limit that. We're also going to reduce the effects on human consumers. So like we're not taking those chemicals into our body either. We don't have to worry about that. We're just not using them. And we're going to have less contamination of surface and groundwater. So yay, it's kind of all those things were big issues that we talked about with the Green Revolution systems. This is going to help fix those. Here's the cons. Definitely time consuming, definitely costly. It takes a lot more research. It takes a lot more planning. And in a lot of cases, it's not quite so quick. Like there's more to it. So that's it. That's the big one. Most of these things are time and money, right? All right. Last piece here when we're talking about agriculture and sustainable agriculture. So the big things with sustainable agriculture is conserving soil. So we want to minimize erosion as much as possible. So we know that the U.S. is losing topsoil 10 times faster than it forms. So soil is actually, and this is a weird thing to think about, soil is becoming a non-renewable resource because it's not being conserved. A lot of these techniques are also going to reduce nutrient loss. They're going to increase soil moisture. They're going to keep decomposers in that topsoil, which is hugely important to soil fertility. And there's going to be organic matter that traps that soil moisture as well. So we're all of these things are, again, making our soil better and keeping it where it's supposed to be. So one of the things is contour plowing, and this is plowing parallel to the natural slopes of land, right? So it's kind of preventing the water from running down. And it kind of forms, let me move my face. It sort of forms these little like terraces, right? So those little terraces are going to catch what's there, keep it from running off. Sorry, my phone's dinging too. It's fine. I should shut that off. The other thing that we have is, sorry, I can't do two things at once apparently. There we go. Is terracing. And this is literally taking the slope and making it so that it's flat little plants. So this does really well where there's steep places that we've planted on. Again, preventing runoff, keeping soil where it belongs. The other thing is planting perennial crops. So one of the things that perennial crops do, they grow year round, or they might have their dormant cycles, but they stay and they just kind of come back, right? So there's never like removing them completely. They stay there. The root systems there get so much more established. And when those root systems are established, it holds that soil together. Also, it's not bare soil between harvests, right? We still have the stalks or the, whatever remnants of those plants are there. So we're keeping that soil from running off. Still going here. Again, don't think you have to write all this, just get the general gist. Windbreaks are another thing. We basically plant trees to kind of stop the wind, break the wind, right? And it helps to reduce erosion of topsoil from the wind. And in addition, it's kind of nice. We can sometimes have a source of firewood or fruit, right? Depending on what we plant. And it's great habitat for other species. The other thing we can do is something called no-till agriculture. So typically what we do when we harvest, we go through and we rip everything up and we kind of till the soil. This would say don't do that. It's going to leave the crop kind of on top of the soil. We are adding organic matter to the soil as we go, and we are also not loosening up that soil as much, so we're preventing erosion. And if, again, depending on what we plant, if we plant the right things that roots can grow even in soil that's not super aerated and tilled up, this works. Lastly, we have something called strip cropping. Same idea as intercropping, where you're planting different rows, like you're planting rows of tall things with rows of kind of lower level density things. So you've got your tall plants, your small plants. Sorry, there's people milling around. I was making sure we weren't getting interrupted again. All around, and you get less runoff from that. All right, the rest of these, and again, don't have to read all this, are involved at increasing or improving soil fertility. So we can rotate our crops because certain crops actually use different nutrients or give off different nutrients. So if we know what those are, we can rotate so that the crops are almost replenishing themselves, which is nice. Okay, we also can do something called green manure. This isn't anything to do with poop, but it's leaving leftover plant matter behind. Again, covering those up, you get the theme here, right? We're leaving the roots, we're not leaving bare soil, we're keeping the soil where it's supposed to be, but also providing a lot of those, or putting a lot of those nutrients back into the soil. It kind of looks like this, right? Which is nice. We can also put limestone down. Limestone, is really good at neutralizing acidic soil, and acidic soil is kind of common everywhere because of acid rain. So if we're adding this, it also helps that. Acidic soil is not good for a lot of things. Plants don't grow super well, but also toxic metals are more soluble in that. So if we make it less acidic, we keep the soil healthier. All right. Rotational grazing is the last one. I think. Okay, good. Again, the idea that having livestock kind of regularly rotate through, you get the theme here. I don't need to say it again, right? We're promoting pasture growth. We're keeping roots where they belong. It's a good system, and it's a natural system. All right, so this is the FRQ you're going to do. A lot of conservation strategies I gave you. Find 2 that you think could be used to prevent soil erosion in already established agricultural fields. So we're not replanting, they're already there. What do you think? Thanks for hanging with. Sorry that was a slightly long one. We'll talk soon.